1.50 and negative exponents. I wrote numbers. It is exponents. Now, to start, I want to review this hands-on activity we did in class. So here we have an expression 3 to the power of 5 over 3 to the power of 2. In this case, it's 5 minus 2 to give us the power of cubed. Here, it's to the power of 5 to the power of 3, so we get to the power of 2. Here it's 5 over 4, so we get to the power of 1. Here's 5 over 5, and we get to the power of 0. Now what expression did you write for 3 over the power of 5 to 3 over the power of 5? You should see 3 to the power of 0. Now we know that 3 to the power of 0 equals 0, because if we have 3 to the power of 1, that's 3 times itself one time. If you have 3 to the power of 0, it's 3 times itself 0 times. So it's like saying we have 0 3's. So anything to the power of 0 is 0. Now, that is our, I'm sorry, I said 0, but it is actually 1. The 0 here is telling us what exponent is, so 3 to the power of 0 is 0. Based on our findings, 3 to the power of 0 is 1. Anything to the power of 0 is 1. Negative 2 to the power of 0 is 1. Anything. Because we don't have nothing, we just have it multiplied by itself 0 times. It's like saying that 3 over 3 times 3 over 3 times 3 over 3 times 3 over 3, all these different numbers equal 1 times 1 times 1 times 1 times 1, which is not 0. 1 times 1 times 1 times 1 is 1. So that is what we're going for here. Now let's start our notes with understand the 0 exponent. So try to understand this in a different way. Now, here's our boxed thing. Remember this, very important. A non-zero number raised to the 0 power non-zero number to 0 power is 1. So a to the power of 0 equals 1, where a does not equal 0. This is very important. This is what we're going to remember. Here's our example 22. A, 7 to the power of 3 times 7 to the power of 0 equals 7 to the power of 3 times 1 equals 7 to the power of 3 equals 343, and that's evaluated. B, 1 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 3 times 10 to the power of 0. So let's solve it. First, let's multiply everything that has an exponent. So 1 times 10 to the power of 2 equals 100 plus 2 times 10, because 10 to the power of 1 is 10, plus 3 times 1, because 10 to the power of 0 is 1. So we multiply these, gives us 100, plus we multiply these, gives us 20, plus we multiply these, gives us 3, equals 123. That is our answer there. C, 4 to the power of 2 times 4 to the power of 6 over 4 to the power of 8. Let's solve the top. Is 4, 2 plus 6 over 4 to the power of 8 equals 4, 8 over 4, 8 equals 4, 8 minus 8 equals 4, 0, which equals 1. D, a to the power of 4 divided by a to the power of 0 times a 3. Let's solve inside first. Inside first is going to be a to the power of 4 divided by, sorry, there's a mosquito on me, divided by 1 times a to the power of 3 equals a to the power of 4. Divided by 1 is still just a 4, so now it is times a 3, which equals a 4 plus 3, which equals a 7. Go ahead and try guided practice. 1, 2, and 3. Understand negative exponents. Let's show our little chart here again. So we started with finding 1 to the power of 2, and then we found 1 to the power of 1 to the power of 0, which we know the answer is 1. But then you start to get to where you have 4 to the power of negative 1, 4 to the power of negative 2. In our little box here, we see that what's really important to figure out is a to the power of negative n. If there's a negative exponent, not a negative number, but a negative exponent up here, it's going to equal 1 over a to the power of n, positive. So if you want this exponent to switch from negative to positive, instead of being on the top like this one is, you flip it to the bottom, and it becomes positive. A does not equal 0. Let's try an example of this. A, 13 to the power of negative 4 times 13, 7. Here's method 1. Method 1 shows us that we can flip this, invert it. So 1 over 13 to the power of negative 4 times 13, 7 equals, 7. 13, 7 over 13, 4. This is a positive. Sorry, got a little messy there. Which equals 13, 7 minus 4 equals 13 to the power of 3. Method 2 shows us that we could just take this and we could use what we already know. So 13, negative 4 plus 7 because they're multiplied, which still gives us 13 to the power of 3. So if you are adding it to something bigger, you don't have to put it on the bottom necessarily. You could just do this method here. Let's try that with B. Method 1, x negative 7 over x 4. It's given to us in this one already, so actually we don't have to use both methods because it's already like this. So we are just going to say 1 over x negative 7, or 1 over x7, sorry, times 1 over x4. The reason we want to do this other method is because they're both on the bottom. We can't move them to the top. Ugh, this is positive. 1 over x7 times 1 over x to the power of 4 equals 1 over x to the power of 11. Sorry if that one was a little confusing. Let's try it one more time. 9m divided by 3m negative 2. Let's put it in fraction format to make it easier to see. 9m over 3m negative 2. Let's split this apart to make our 9 over 3 by itself times m over m to the negative 2. And now let's take that negative 2, raise it to the top, carry over 9 over 3, times m, this is a 1, so we can do 1 minus our negative 2 because it's division. And we know 1 minus this whole thing turns into a positive, so it would equal 9 over 3 times m to the power of 3, which equals 3m cubed. Go ahead and try that on your guided practice. 4, 5, and 6. And that's all we have for today. Pretty short lesson. We'll see you in class tomorrow.